Hello everyone, we are Xiaohong Lin, Zhongxin Lin, and Kaixuan Wu. Our group chose to design a low-cost, low-energy, climate-responsive facade in Guangzhou, in the hot and humid climate zone. Firstly, we will introduce our design aims. We focused on three aspects: natural ventilation, daylighting, and air dehumidification. We considered designing proper roofers and facade geometry for natural ventilation, proper shading for introducing indirect and glare-free sunlight, and using proper fabrics for dehumidification. The facade is designed to be south-facing. This is because south-facing facade can not only take advantages of the prevailing winds from southeast in summer, but also effectively moderate the overheating and the glare in summer. As shown on the picture, the facade is designed to be wave-shaped using bamboo or cane-based materials, which are moisture absorbable. This facade geometry can assist in facilitating natural ventilation for the building. The facades are openable through rotated louvers, which are automatically controlled by computer according to the external environment. The central hung louvers were set considering the balance of each piece and the uniformity of all pieces. Otherwise, the louvers will be the combination of top hung and bottom hung pieces.
For each louver piece, there are 4 different opening angles: clockwise, anti-clockwise 45 degrees, and clockwise, anti-clockwise 90 degrees. The initial intention of the facade is to respond to the external environment in 2 modes. The first mode, as the left diagram suggests, is to block the direct sunlight. Under the circumstance, the related louver on upper arcs are controlled anti-clockwise 45 degree open, and those on lower arcs are 90 degree open. The second mode was inspired by wind catcher. Since the wind blowing to the convex surface will naturally flow to the concave surface, the wind can be caught into the building by the opening louvers. This mode was controlled on when the speed of south wind reached a certain threshold, and all louvers on upper arcs are anti-clockwise 45 degree open, while those on lower arcs are clockwise 45 degree open. In addition, when the wind passes the louver, the bamboo or cane pieces with high hygrous capacity can be observed. The moisture in the wind can be demulify the incoming air.
However, several problems exist in the current design. The first is the central hung louvers, which essentially are not ideal for viewing, and this opening type also limits the shading depths. The second problem is the difficulty to design a proper bracket. Because to support a wave-shaped facade, the bracket should be low-bearing and stiff enough to carry louver pieces, and meanwhile not spoil the aesthetics of the facade. In addition, since we consider using bamboo or cane-based materials for louvers, the durability of those louver pieces can be a problem. It suggests that often maintenance and potential replacement are necessary. Also, bamboo or cane pieces mainly absorb moisture in the surrounding air, not in incoming wind, so the effect of dehumidification is rather low. And finally, let's look at the cost specification, including louver pieces costs, bracket costs, joint element costs, installation fees, control system and sensor costs. All costs were referred to the current Chinese market. Since the materials of louvers and bracket are local source, the cost of which is low, So overall, excluded the uncertain costs of control system and sensor, the 2 meter times 1 meter facade unit costs £38. That's the end of our presentation. Thank you for watching.